Hello, everyone. Mr. Minnick is my name. Math is my game. Today, I'm joined by a very special class who's excited because of today's date. We've got a guest speaker who would like to tell you a thing or two about today.
Hi, I'm Seth Morgan, and today is the third all day and half the night. Thank you.
All right. So, here we are in Algebra 2. We're kind of deviating from the normal sequence, and we're studying the unit circle. The unit circle. And up to this point, we have defined what the unit circle is. We have realized that there are 16 reference angles upon the unit circle. And we have memorized the measures of all 16 of those angles in degrees. And we also mentioned that there are coordinates at each of those 16 reference angles. There's actually one 17th angle that's coterminal with one of those reference angles. Maybe I could get a volunteer from this class to come on down and fill in the circle in degrees. So while they're doing that, kind of like shoes, there's two different ways to measure angles. And we're going to be talking about those today. You know, with shoes, you wear your American-sized shoes, and then there's that, isn't that there a European sizing as well? So I think like if you wear 10s in American, that's like 44 in European sizing or something like that. I don't know. Something like that. So notice that 0 and 360 are coterminal with one another, and then moving around through the first quadrant, we've got 30 degrees, 45 degrees, 60 degrees, 90 degrees, 120 degrees, 135 degrees, 150 degrees, 180 degrees, 210 degrees. And we're making our way on around the circle. Remember a couple little pointers along the way, 15-degree increments inside. So we got the 240, the 270. I really wish I could write that next one out in words. I would write THREEHUNNIT, 300. And then 315, and then the 330. And then we've got the right multiple choice answers too. B, B, D, C. Right. Yeah. Good. Good. Thank you. Thank you to our volunteer for filling in all these angle measures in degrees. So degrees are something that we're pretty familiar with, right? Okay. Well, in a minute, I'm going to try my very best not to scare you, but I'm going to put a definition on the board that is not crystal clear. So this new angle measure is called a radian. And here's the definition of it. If I wanted to talk about motorcycles, I would say a radian is a 1984 Yamaha 600cc inline four-cylinder motorcycle. But that's not what we're talking about today. A radian is the central angle formed by two radii. That's a weird word. Radii, that's the pluralization of radius. So by two radii and an arc equal in length, and length has a G in it last time I checked. So a radian is the central angle formed by two radii and an arc equal in length to a radius. I remember reading this the first time and I said, you know, I understand why people don't like studying circles, why people don't like math, because some of this stuff is a foreign language and without interpretation it doesn't make any sense. ¿Cuántos años tienes? Yo tengo 39 años. Varum. Anybody know what varum means? It's what you do when you're playing car. You start it up. Varum. No, it's actually, in German it means why are you, it means why. in German. But anyway, so we need some kind of interpretation of this. So here comes the circle. There it is. I really wish, could I have a volunteer to come on down and put a little dot right where the dot center is of that circle? Thank you. I'm going to try not to make it any bigger or smaller, but well, either way, just put a dot on that. No, on the dot that's there, because it's going to go away. Thank you. Appreciate that. I don't know what I would have done without that. So, what's that thing called if we go from the center to the side with a straight line? What's one of those called? That's a radius, yeah. So, I'm going to make this line a little thinner. So here's a radius. Okay. And then I need another radius like that, maybe. And what I'm about to do is trace along that. And here's where things are a little challenging. What I need to do is not draw another circle. I didn't mean to do that. What I need to do now is take this and turn it down. Turn down for what? It'd be great if I had a clip of that recorded. I could play that back. But so what I need to do is somehow take that thing and fold it, curve it so that it curves around the circle. Does everybody see what I'm doing after there? It'd be nice if I had a piece of string I could simulate that. So what we're saying is when we're talking about a radian, it's that central angle formed. Does the central angle, does that mean the outer angle or the inner angle? It's the inner angle. So this is what a radian is. A radian is that angle, and it has a certain measure to it. So right there, that's how big a radian is. And you're probably saying, well, what does that have to do with the unit circle? Not much. It is another unit of measure that we're going to use to study the unit circle, but does anybody know how many degrees that is? How many? 30? It looks bigger than 30 to me. 65? That's getting closer. 45's worse. 82? No, it's not 82. 60.57, we're getting closer. 72 is not so close. 60 is pretty close. 68's worse. 61 is not as close as 60.57 was. 50's not so close. I'll say lower or higher. It's lower than 60. 58, it's lower. 56, it's higher. 57.7, it's lower. 57.6, it's lower. 57.4, it's lower. 57.5, it's lower. 57.3, it's a little lower. It's higher than 57.2. We're getting close. 57.2957, whatever. Who knows? Who cares? Let's see. If we could somehow measure this with a high circle, that circle keeps repopulating. Anyway, that actually is a pretty good drawing. It's about 57.3 degrees, okay, approximately. How does that help us with the unit circle? It doesn't. There's one conversion factor that we need to know. Now, somebody could probably guess where that 57.3 comes from. Has something to do with pi. Pi is 3.14, right? It has something to do with pi. So here's this converting factor. Here's a magic expression that you need to write down. This is kind of like your decoder ring. 1 pi radians. 1 pi radians is equivalent to 180 degrees. So when we came up with that degree measure, if we take 180 degrees, divide that by pi, that tells us that 1 radian is 180 divided by pi degrees, and that's where the 57.3 comes from. So we're trying to relate this to the unit circle, and yes, the question is straight across at the west side of the unit circle, that would just be pi, correct? Good. And remember a couple weeks ago a couple months ago now when we studied fractions? Being able to know fractions and count by fractions is a very crucial skill. Also, knowing when and where to take your shoes off is a crucial skill. When you go to some people's house, like my drummer's house, you have to take your shoes off. And sometimes it's going to smell a little bit, and sometimes it's going to sweat up the floor, and it might stink. But sometimes you have to know when to take your shoes off. So we'll get to that in a second. Before we get to the unit circle, let's just think real quick about another one. If 1 pi radians is 180, then 2 pi radians would be how much? 360. Good. Is everybody on point so far? Everybody got this? Good. Felt good to do that. I haven't done that in a while. So now, if you need more unit circles, I've got some. If anybody goes to GHS and would like some unit circles and they're watching this, I've got plenty in my room. There's plenty of copies of it. So what we're going to do is we're going to break this down, and we're going to take it kind of slow going around this because I don't want to leave anybody in the dark. It's not just the dark, it's in the dark. Yeah. Two dark squared, there we go. Isn't there a song that says in the dark? Yeah. Oh, in the dark. Okay. Yeah. All right. So let's see. So 0 degrees is also 0 pi radians, and it's also the 2 pi, yeah. So 0 and 2 pi is right there. For the record, we had mentioned coterminal angles before. You don't need to write these. I'm using my magic marker. Check it out. In addition to 2 pi being there, so would 4 pi, and so would 6 pi, and so would 8 pi, and so would 10 pi, right? Any even multiple, any even number with a pi beside it, that's going to be there as well. They're all coterminal. So we said over here is pi, and now's the time where we got to be good with fractions. What's halfway between 0 and 1? 1/2. Now keep in mind there is pi on the side. I don't know if anybody likes to eat at restaurants, but the next time you go, I want you to try something. Instead of getting pie after you eat, order whatever dessert you want, probably pie. Order pie first and eat it first, and don't feel bad about it. It's going to be so good. It'll be worth it, trust me. So anyway, so it's 1/2 with pi on the side, but I mentioned the housekeeping. If I go to my drummer's house and I go in there with my shoes on, he's gonna kick my butt, and he could too. Well, anyway. 1/2 pi. We don't write it like that. We're just going to write pi over 2, okay? So we're just going to write it as pi over 2. Now, I mentioned being able to count by fractions is a very valuable skill, so let me get out my little wonder wheel here. I love this little ray. So if I go have to do this on the keyboard. If I take my ray, there's 1 pi over 2, right? 1 pi over 2. Now, that was going halfway around the top. So if I go an equidistance, that's 1 pi over 2. So this is 2 pi over 2. Well, what does 2 pi over 2 simplify to be? 1 pi, right? At the bottom, what goes at the bottom confuses some people. What goes at the bottom, it's 1/2 of a pi past 1 pi. So some people might say, well, 1/2 of a pi past pi is 1.5 pi. But that's a mess. You just walked into a Japanese person's house with your muddy work boots on. They're not going to like that. That's very disrespectful. anybody's house, it's disrespectful, let alone somebody who doesn't want you in their house with their shoes on. So we're not going to write it as 1.5 pi. How are we going to clean that up? Yeah. 3 pi over 2 would be the winner chicken dinner. Good call. So instead of 3/2 pi, we're going to write it as 3 pi over 2. Okay. So again, with this counting by fractions business, 0/2, 1/2 pi, 2/2 pi, 3/2 pi, and 4/2 brings us back to 2 pi, right? Is everybody all right with that so far? Good. So remember, I like to call those the P-O-L-E-S, poles. Has nothing to do with them being Polish, because they're not. So let's move on then to what I like to call, I call them the quarters, and it's for a good reason. I also call them the corners, and you might see why in a minute. There's actually somebody in our class that what's to come here pretty soon reminds me of, and I've been talking about this person all day. So let's see. What's halfway between 0 and 1/2? 1/4. So we're going to write pi over 4. Everybody good with that? Okay. Again, being able to count by fractions is a very critical skill. 1/4. So every time we go 45 degrees, it's 1/4. Another 45 degrees would be 2/4, but that reduces to 1/2, right? Okay, so what's next then? 3/4. And it's 3 pi over 4. Good. Awesome. 3 pi over 4. Okay? So again, counting by fourths, 1/4, 2/4, 3/4, 4/4 simplifies, so we don't need to write that. So down here in the third quadrant then, we're going to have, it's 1/4 past 4/4, so it's, somebody said it, say it loud, say it proud. 5/4 pi or 5 pi over 4, right? 5 pi over 4. There we go. So far, so good? Again, with this counting, 0, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. So what's going to be in the fourth quadrant then? Is it 6 pi over 4 or 7 pi over 4? 7, because we just went 45 takes us to 6 pi over 4, but that's 3 pi over 2 because we know how to reduce fractions. So in the fourth quadrant, we're going to have 7 pi over 4. Okay? What do we think about that? We doing okay? Questions, comments, concerns, short debates, long debates? Got a question? The next one's in the first quadrant are pi over 3 and pi over 6. Good. Somebody's been doing a little bit of advanced work on getting these down. I'm glad. That's awesome. That is terrific. That's good. I can't wait to see the results of the next quiz. So I did mention that I called those things the corners. What does that kind of look like? An hourglass? Doesn't it look like something that somebody might wear up on their dress shirt on a game day? A nice little bow tie? What I want you to realize is if you draw those diagonals like that, notice how the denominators are the same? That's going to happen North Pole to South Pole. It's going to happen coast to coast with the whole number for the pi and the 2 pi and then even the 0 pi. And then, across the way, all those bow tie angles are going to share a common denominator. Does that make sense? They're called bow tie angles, some people call them. I think it's kind of cool. Okay. So the next ones, we had somebody mention that they are pi over 3 and pi over 6. So let's think about this. Let's start with this 30-degree angle. How does 30 compare to 180? It's 1/6 of it. I guess we'll go to this one next. So these will be sixths. S-I-X-T-H-S. That's tough to say. Sixths. So it's 1/6 of a pi. So it's pi over 6. Now sometimes it's okay to count by fractions. And sometimes it's best to be like a big fine woman. Now you probably know what that song, Big Fine Woman backs that thing up, right? I'll be honest with you, the sixths are the ones that most people struggle with. Let me sketch in my bow ties here. Okay? So here's going to be a sixth, here's going to be a sixth, and here's going to be a sixth, right? If you can count by fractions, it's tough to count by sixths sometimes. Check this out. Because there's 1/6, 2/6. Yeah. 3/6, which is half. So it's not necessarily a good idea to count by sixths. So let's think over here on the West Pole. How many sixths is 1? It's 6/6, right? Is everybody good with that? So let's be a big fine woman and back that thing up. If we back it up from 6/6, if we back it up 1/6, how many is that going to be? 5/6 pi, right? Everybody get that? Now, we can do the same thing, but instead of backing that thing up, let's go forward. If we go forward from 6/6, what's that going to be? 7/6. Good. So 7 pi over 6. And let's go all the way over then to the side here. How many sixths is 2? That's 12/6. So again, let's be a big fine woman and back that thing up. Backing it up from 12/6 is 11/6. Okay, so it's 11 pi over 6. How do we feel about those bow tie angles? Good. Good. It's a lot when you see it all together. It's a lot to fathom, to think, oh my gosh, I got to memorize these for tomorrow's quiz. Well, let's take a look at the thirds next. The thirds, 60 degrees. How does 60 compare to 180? 60 is 1/3 of 180, right? So let's go to our third bow tie angles. So here's 1/3. Can we count by fractions? All right, let's see if we can count by fractions then. Let me make this red. So there's, whoop, I said let me make that red. There we go. So there's 1/3. So when we go over here, that's going to be 2/3. So 2 pi over 3. All right? We're good at counting by fractions. 0, 1/3, 2/3. Every time we go 60 degrees, every time we go 60, there's 60, there's 60, there's another 60. That's 3/3, but that's 1. We already got that one. 2/3, 3/3. What's going to be down here in the third quadrant? 4/3. So 4 pi over 3. What about down here in the fourth quadrant? What do we got? Somebody said it. 5 pi over 3. Good. 5 pi over 3. Okay? So in a minute, we're going to put this all together. Before we do, does anyone have any questions, comments, concerns, short debates, shout-outs they'd like to give? We got a shout-out?
I'd like to give a shout-out to myself, Seth Morgan.
Okay.
Shout out to Cali File.
Oh, we're going to have limited time on this. You'll have more time on the quiz that you're going to be filling these in for sure, because this is going to take a long time. Some people are better than others in counting fractions. So some people like to have a way to help memorize things. So here's just an observation that I've made. I think, therefore I am was a quotation by Socrates, but I really think that if you have been paying attention, there's no excuse to miss the east and the west poles, right? It's kind of like our country. Everybody knows what state is on the west coast. At least one state that's on the west coast, right? California. And everybody knows at least one state that's on our east coast. New York, right? Because from New York City to Britain, you would swim across the Atlantic to get to Great Britain. Maybe. I might take a boat. But anyway, once you get beyond that, check this out. Watch what happens with the fractions. We got over 2 in the top and we got over 2 in the bottom. Remember, 180 degrees out from each other, they're going to be the same, and then the bow tie angles are always going to be the same too. But check this out. There was a wrestler back in the day named Ric Flair. And if you understand what flare is all about, watch what happens when we flare out. Let's forget about the bottom for a minute. Let's flare out from the 2. When we flare out from the 2, it's going to be over 3. Then it's going to be over 4. Then it's going to be over what? 6. Again, back to the top. Let's flare out from the 2. From the 2, we flare out with a over 3 and a over 4 and a over 6. Yes? Let's go to the bottom. Flaring out from the 2, we're going to have a denominator of 3 again, and a denominator of 4 and a denominator of 6. Flaring out from the 2 again, we have a denominator of 3 and 4 and 6. Does that seem reasonable, sensible? I think it'll help some of you. Quadrant 1's a piece of cake because it's just one of everything, right? Quadrant 1 is one of everything. Make sense? Except maybe when you look at the terminal ray, then that's a little confusing. So here's where it might be fruitful, helpful, handy to be able to count with your fraction counting. Where do we want to go next? To the thirds? Okay, so there's 1/3, so then it's going to be 2 pi over 3. All right? Now, where do you go from here? Do you finish off the thirds? Or do you go in order? It's up to you. Finish the thirds? That's not a bad idea. 1/3, 2/3, 3/3. 4/3 is going to be the one down there. So 4, come on. You could do it. 4/3 and 5/3, right? And then there's 1/6. So let's back that thing up. So we got 5/6. So 5 pi over 6. And then advancing that thing 1, we're going to have 7 pi over 6. And then if we go across, remember 2 was 12, so backing that thing up is going to be 11 pi over 6. And we're almost done. We got what, 3/4 pi? And then how many fourths in the third quadrant? 5/4 pi. And then 7/4 pi. And I forgot due south. I forgot about the South Pole. 3 pi over 2 in the south. That's it. It's been real. It's been fun. I'd like to give a shout out to the future Mr. Minnick for being such a nice guy. Another shout out or question? Second and third quadrants. We got an idea here. Let's hear it.
When you have the frequency with like 2 pi over 3, if you look down, 2 added to each of the other one above it.
So we're looking at the 2 pi over 3, and then the next one down here like this. So if you add 2 to each of them, you keep getting a number below it. I kind of see what you're going for there. That's kind of cool. 2 over 3, 3 over 4, and I see. That's cool. That's cool. So from there to here, then it gets 2 bigger. Okay, cool. Anybody else have any thoughts, comments, concerns? Well, that's it. It's been real. It's been fun. I hope everybody is learning the unit circle and has a great day.